Every neural network, from the one tagging your photos to the one writing your emails, is built from a unit so simple you could run it on a calculator. Here's what most explainers get wrong about neural networks. They make them sound mysterious. Diagrams with glowing nodes and animated pulses. The reality is far less cinematic and far more interesting. A neural network is just math arranged in a specific shape, and that shape is what gives it power. So let's build one from scratch. Start with a single artificial neuron. It takes in some numbers, say pixel values, from an image. It multiplies each input by a weight, which is just a number that says how much that input matters. It adds up all those weighted inputs, tacks on a bias, a small nudge, and then passes the result through an activation function. That function decides whether this neuron fires or stays quiet. That's the entire unit. Multiply, sum, nudge, decide. Now here's where the shape matters. You arrange neurons into layers. The first layer, the input layer, receives raw data. The last layer, the output layer, gives you an answer. Cat, dog, 0.97 probability of rain. Everything in between is a hidden layer. And stacking hidden layers is exactly what deep learning means. It's not a different kind of AI. It's the same neuron, repeated and stacked deeper. Why does depth matter? Because each layer learns to detect something slightly more abstract than the one before it. The first layer in an image network might detect edges. The next combines edges into shapes. The next combines shapes into eyes, ears, whiskers. By the final layers, the network recognizes a cat, not because anyone told it what a cat looks like, but because it assembled that concept from simpler pieces, layer by layer. But here's the honest version of how this starts. A brand new network knows nothing. Every weight is random, it produces garbage. It only becomes useful through training, seeing thousands of examples, measuring how wrong it is, and adjusting those weights a tiny amount each time. The learning is in the weights. One more thing worth being precise about. They're called neural networks because they were loosely inspired by biological neurons, cells that receive signals, process them, and pass signals onward. The analogy holds at that high level. But biological neurons operate with chemistry, timing, and structural complexity that artificial neurons don't remotely replicate. It's a useful metaphor. It's not a blueprint. Every AI system you interact with today runs on this architecture. Understanding it, even at this level, means you stop seeing AI as a black box and start seeing it as engineered math with a specific knowable structure. If that was useful, subscribe. New Explainer every week. I'm Ariella.